victories and tragedies and these feelings. As of March 2025, according to incomplete accident records, fatal major accidents caused by 22. A total of 64 soldiers were killed in the air crash and on the ground. 53 people were injured. Since its inception, 22, it was always considered an unsafe aircraft, even earned the nickname Widowmaker. November 2023, off the coast of Japan, 3 CV-22 plus British, after completing refueling and maintenance at the bases along the country, prepared to perform a routine training mission. 3 Ospreys, to take off, aerial refueling drills with a C-130, and skydiving. The 3rd Osprey followed an hour later, provide support. The 2 lead Ospreys, the Gundam 21 and the Gundam 22. There were 23 crew members on board. There are 15 people on the 21st. Gundam 22 has 8 people. After 40 minutes of flight, Gundam 21 sees Gundam 20 to start flying east, deviated from the original southbound course. Then Gundam received another message on the 21st. This is the first time for the crew, and the only time an emergency was mentioned, while waiting for the runway to clear. Cloud Eagle before landing. Last right turn circled. 300 meters above sea level. The left nacelle suddenly caught fire. After 6 seconds, the Cloud Eagle rolled violently, falling from the sky and falling into the water. Then all US troops stationed in Japan were immediately grounded. A search and rescue operation began immediately, lasted 48 days. 1 month later, divers near the crash site, 30 meters underwater, found the main body of the fuselage and the 8 crew members on board. This plane crash, just one of the many fatal accidents of the Osprey. What caused the accident? Let's start with the official results announced by the US military. When the V-22 Yang plane was salvaged, investigators' tests of the left nacelle, no fuel or hydraulic contamination was found. After cleaning up from the spiral, a damaged gear in a propeller gearbox. It is obvious that the gearbox is malfunctioning. The transmission chain shows severe wear and tear. Gear teeth are almost flattened. But why is this happening? This fall through Japan, the cause of the accident caused by the destroyed Osprey. Take this opportunity to disassemble the mechanical structure of the V-22 in depth. Is V-22 safe? Bell-Corpo ratio. And Boeing provided 3 options for the US military. Reverberant variant, MV-22 for Marine Corps transportation and rescue, CBA-22 for US Air Force special operations, and CMV-22 for naval supply. The core feature of the V-22 Yang is its unique light rotatio suspense system. In helicopter mode, pilots use helicopter controls by fly-by-wire system to control the actual operating mechanism, total pitch of propeller rotor blades, to enable the aircraft to hover, and by changing the total distance of the blades in the opposite direction to control roll, by combining the 2 rotors, tilt in the same direction to achieve parenting, by turning the rotor, tilt in the opposite direction to control deflection. This precise control, it's a V-22 that can hover very easily, and vertical landing. The control surface of an aircraft consists of negative wings, rudder, and elevator. Take over the main control functions, switching between helicopter mode and aircraft operated by a pilot. A small knob on the device controls. Just use your thumb. The crew can adjust this knob. He'll send a signal to the fly-by-wire system during a short descent. The actual nudge mechanism is located on the edge of the gold wing. Use. A hydraulic motor rotates a long telescopic screw. One end of the screw is attached to the wing. The other end is connected to the nacelle. As the screw extends, the nacelle slopes up. Another aerodynamic compromise for 22. It's the propeller. Torsion angle of rotor blades. The torsion angle of a helicopter blade is usually about 8 degrees but 20 to propeller. The rotor is much faster in the oncoming airflow. Also needs to work as an efficient propeller. In order to deal with this, the propeller rotor has a twist angle of 47 degrees. Although this increases the efficiency of forward flight, but at the cost of reduced hover efficiency. By overloading the river, it measures the weight of its aircraft against rotor circle ratio of shape area. The rotor passes and pushes the air down to generate upward vitality. For helicopters, by moving a lot of empty space slowly, it creates this energy, easier than moving a small amount of air quickly. The V-22 is heavy and the rotors are small, resulting in inefficient hovering. Higher onboard core. This kind of high-volume consolidation means that in order to hang flat, Ospreys need to be faster than helicopters, push down for more air. For helicopters, This downwash is usually about 60 knots. The Hurricane had winds of about 64 knots. The downwash of the V-22 is 80 knots. This could enable the operation of the ground crew. Becomes a little difficult. Osprey's nacelle, light turns and complex machinery. It relies on 5 gearboxes and a complex axis, a network of systems to operate. This poses a high risk. Each component is an additional point of failure. So how does the system work? During that training flight in Japan, so what's wrong? The Osprey's propeller gearbox is almost identical. The key difference is the right gearbox. It's missing a gear, so that the rotor can rotate in the opposite direction. This plane has 2 turbine engine and an auxiliary power unit to provide power. The auxiliary power unit helps to move the entire. The assembly rotates to a position parallel to the fuselage. This was stored on an aircraft carrier. Necessary function in helicopter mode. Even with the V-22 propeller, the rotors rotate slightly differently. Can also generate significant asymmetric forces. Leads to instability and greater rolling motion. To prevent this, propeller. The rotor is like any other twin-rotor helicopter, connected by a shaft, but unlike traditional designs, the suspense of V-22 is not connected by a straight line. They're connected by wings. View from above, you'll notice that the wings of the V-22 are slightly forward. That's not very common in airplanes, but it's not all about the aerodynamic. The front is a large propeller. The rotors provide enough clearance to avoid collision with the wing. If it is a straight wing, need to turn the heavy light nacelle, push further out. This will result in more structure and aerodynamic challenges. From the front, you'll also see the wings tilt up slightly. The angle is only 3.5 degrees. This subtle back and forth bridge not only does it increase stability in airplane mode, and also make sure that when the wings are folded, parallel to the fuselage, for storage, the nacelle has enough clearance, can rotate smoothly into place. So the axis of V-22 is not a continuous straight axis. It's divided into 6 sections to accommodate a 13-degree wing angle and distributes power between the engines. In order to, if necessary, the V-22 can be powered by a single engine, but the nacelle is not rigidly attached to the wing, so an extra gearbox is required. Light shaft. The gearbox diverts power from interconnected shafts, transferred to the propeller, rotor gearbox. No matter what angle the nacelle is at, but the gearbox needs to be, to keep everything running smoothly. Reduce friction and get gears right Nirvana oil. It can also be used as a monitoring gearbox. Way of health. Because gears shed tiny, harmless particles when they wear out, called detritus, especially during the break-in period. The real problem is that when the gears fail, will produce larger metal fragments. We need a system to detect and remove the debris without having to open the gearbox and change the oil. Can be in the oil flow. Place a small magnetic detector to attract metal fragments. He has to open touch points. When metal fragments come into contact with them, they close. It's like a switch. Then there will be a pulse of electricity through the debris. Melt it down. Larger fragments require more energy and pulses. If a fragment is too large to burn off, the system will alert the pilot. It's this debris detector was triggered in the Cloud Eagle crash. Each propeller, rotor gearbox. There are 3 separate debris detectors. They work together to collect and burn the debris. From the conversation between U-Tower and other lingering voices, investigators knew before they found the plane. Something is wrong with the debris detector. I just don't know which part is faulty. The plane was salvaged from the ocean. Flight log. Filled the dialogue with the tower and Sister Yu Ying. In half an hour left blank. The system reports that 5 fragments have been successfully burned. The protocol says an alarm is just a warning. But once the debris burns 3 times, the crew is due to land if feasible. However, whether or not to land is at the pilot's discretion. In this case, the crew believes that the alarm is detected by faulty debris caused by detector. 3 minutes after the 5th fragment burned, system issues warning. Said there was a fragment that couldn't be burned. The crew decided to change course. For unknown reasons, crew choose to land at a 15-minute flight from an airport in Mai, although there are closer and more suitable options nearby. Voice recordings show no sense of urgency, and once the pilot makes a decision, there was no further discussion of this option. Unfortunately, when Yu Ying entered the final stage, fire in left nacelle, causing catastrophic failure of the propulsion system. From that moment on, the crew was unable to save the plane. After the plane was salvaged, test of the left nacelle, no fuel or hydraulic contamination was found. 3 debris detectors were dismantled. There's debris all around. After cleaning up, Investigators confirmed they were operating normally. From the propeller, a damaged gear in the rotor gearbox. It is obvious that the gearbox is malfunctioning. The transmission chain shows severe wear and tear. Gear teeth are almost flattened. After the plane crash, the Cloud Eagle fleet has been grounded for several months. For example, June 2022, a clutch failure caused the crash. 5 Marines were killed. In that incident, the clutch is wearing out faster than expected. A rare double clutch combinatio make it impossible for the pilot to save the plane. This series of crash worlds renewed concerns about the safety and security of the V-22 project. Reliability questions. Like any pioneering technology, the introduction of the world's first light hovercraft, it involves a steep learning curve. The large capacity of V-22 means these accidents are due to the large number of people on board and bring greater risk. In 2000, during a training exercise, a V-22 lingering sound, descending in helicopter mode, going too fast and crashing, resulting in the death of 19 crew members. Since 1992, there have been 25 incidents involving V-22. 9 of them were lost by pilots. 10 cases were caused by mechanical failure. 2 is a combination of the two, but with the other 2 helicopters, Sikorsky H-60 and Boeing CH-47 Chinook. Since its debut in 1979, there have been 390 incidents with H-60 and its Diversio, resulting in 70 deaths. 60 of them have occurred in the past 10 years. More deaths than V-22 in the past 30 years. More than 2 people in history. Mortality rate of 47 slaves in media events. It has always been the tallest in the U.S. Army. Between 1966 and 2005, in 10 non-combat aircraft crashes, 238 people lost their lives. But in recent years, CH-47 Chinook, there has been a huge improvement in terms of safety. There were 47 incidents between 2016 and 2020. There were no fatalities. Just comparing deaths, that's the accident rate per plane. The performance of the V-22 is quite good. There were only 0.06 to 5 accidents per aircraft. The data for H-60 and CH-47 are respectively 0.75 and 0.11, but if you consider the flight time, V-22 kills more people per 100,000 flight hour. The data points to several trends. Large aircraft like the V-22 and CH-47, the death rate from media accidents is often higher because they can carry more people. Compared to smaller aircraft like the H-60, the risk of each crash is also greater. And more complex aircraft are usually developed in the early days. There will be a spike in accidents because to find and solve problems. But as airplanes have matured and system improvements, these questions, they tend to decrease over time. Plane crashes don't always tell the whole story. Some aircraft are what is considered it was unsuccessful.